many are there? Two guys are there. Okay. Yeah. Yeah. Hi Ravi. Yeah. We can start, right? Okay. So tell me, guys, what's the current status of yours? Okay, each one. We can start from Ravi, then Rahim, then Pavitra. Okay. So up to where you completed and what is your current status? According to that, I will give you the task and all. Okay. And you need to tell the like time period, how long you are been here. From yeah, all those things. Starting from Ravi, you can start.
Uh, yes, sir. Good evening, everyone. I am Ravi Vinay. I have completed my BTech in Electronics and Communication Engineering branch in 2021. After the completion of my BTech, I joined as a quality analyst in SCW Private Limited. Later, I have cracked the gate and I have joined in IIT Kharagpur for the specialization of instrumentation and integrated electronics. And currently, I'm in my third semester of my course. Yes,
Okay, so you are in third semester of IIT Tech.
yes, sir, yes, sir.
Okay, cool. So, and your current status from here as a DB engineer, what are the things you know till now?
Uh, I mean, Currently we have been our placements are going to start. Currently
Hmm.
placement tests are going on, and interviews will be starting in by this month end. So, for hardware engineer roles, the companies are visiting us, sir. So
Hmm.
mostly I will be interested in those. I know Verilog
Hmm.
and digital and all, but I'm not aware of system Verilog and all.
Okay, so
So,
you are looking for the hardware
Yes,
RTL role.
for hardware engineer roles, companies are visiting us. So
Hmm.
so Ravi is in the RTL and verification course. He have almost
Hmm.
completed the 60% of the syllabus. Rahim
Hmm.
is in the PD. He will give the interviews of like digital and Verilog and PD basics. And Pavitra have almost completed the course. Fine. So accordingly, you can ask the digital and Verilog. Fine.
Okay, okay. So
Yeah.
he
And
will
basics
tell
of
you
PD.
that.
Okay. Okay.
Okay.
and for PD roles also, some companies are visiting us. So basics of PD, I should also know.
Yeah. Okay. So Pavitra is completed the full course, right? Okay. Yeah. Okay. Start. Okay, I will start from Ravi. Okay.
Yes, sir.
Okay. So you have cracked the gate also. Okay. You only know about the Verilog only, right?
Yes, sir.
Okay.
In verification.
So for yeah, for the hardware design and like designing, okay, for the RTL, we are only using the Verilog language only.
Yes, sir. Yes, sir.
Okay. Are you aware of any other language we were used?
System Verilog, I'm not sure, but
Hmm.
C. Okay.
For the hardware design, I'm asking.
No, no, sir. No. VHDL, I am not. I don't know.
Okay. So what about your thought, Rahim? We are using Verilog
Actually,
only to design
no. There are other hardware languages as well. That is VHDL also.
VHDL also. So Verilog and VHDL we are using.
Yeah.
Okay. Then tell me one thing. Why the Verilog is quite familiar compared to that VHDL? Now companies are asking for now the VHDL background, right? Why it's like that?
Verilog in
Sir,
general is a
Yeah. Pavitra, you can tell.
sorry, is the
Yeah.
interview is for only Ravi or for three of us?
Sorry.
Should we answer? Is the question is for only Ravi or
No,
sure
no, no, no,
he
no.
also does?
I will come to you also. Okay, so I'm pushing for Vinay, and you can also interrupt. Okay, I will come to one by one. Okay. Yeah, yeah. Now you can tell your answer for the same question what I asked. Why the companies are now is preferring for the Verilog, right, compared to VHDL. Yeah, Pavitra, you can tell me.
When it comes to Verilog than VHDL, Verilog is most readable and easy to code.
Hmm.
And while coding, coding is much easier. And we do have more constructs in Verilog than VHDL.
Okay. Okay. That's one thing. Then Rahim mentioned, sorry, Ravi mentioned that C also used for the designing purpose. Is that correct?
Yes, sir. C-based Verilog design.
No, no, I'm asking for the RTL coding, design coding. Okay, something you are digital, you are coding that need to be like hardware language, right? We are going to convert the actual gates, right?
Yes, yes.
Okay, so do we have the facility to write the code in the C and convert it into actual circuits? That's my question.
No, no. So that is the, I mean, basic difference between normal programming language and hardware description language. In hardware description language, we are describing the circuits, hardware circuits by coding it. In various in programming languages, we are describing some operations. So which will be performed in some hardware which are being developed in this
Yeah,
hardware.
that's okay. Yeah, my question is that C, the C programming language, can you describe the hardware by the C programming language?
uh, I'm not sure exactly, but I came to know that there is some C-based Verilog design. I mean, C-based hardware VLSI design also. So it might be the case, but I'm not sure.
Okay. So meanwhile, Rahim, you are from physical design background, right? Okay.
Yeah, I'm looking for the
Yeah,
physical design.
take your note and design one circuit for the like mode 9 counter. Okay, up down counter. Okay. Yeah, you
And
are aware of yeah, up down counter. You are aware of that designing the Boolean algebra and gate level, all those things, right?
yeah,
Yeah. So you are aware of to design some mode 10 counter and mode 9 counter
okay,
upcoming
mod
orders.
9. Okay.
Okay, you can okay mode 10. You can show me a mode 10 counter. Okay, okay, yeah. Coming to Pavitra, you completed the system log also, right?
Yes, sir, I have completed the
Okay. So
system.
I have the same question for you. We have the facility to write the C-based VHDL code, and we created the hardware using the C language.
Um, I think no, sir. Using C language, we can't create any hardware. Hardware description only with VHDL and Verilog, but not any other language.
Okay. So if we have some C code, can we convert that C code into Verilog codes? Like
Yeah,
any AP? Yeah. Hmm.
that is possible through some again a hardware called an assembler or any embedded systems that we have. We can use that to convert that to C language into VHDL.
Okay. Okay. Uh, so Ravi, I will give you one question. You are aware of the Verilog coding, right?
Yes, sir.
Okay. So do write one code. Okay. Write one code for the RTL code. Okay.
Yes.
Okay. That code need to be one counter. Okay.
Counter. Okay.
Okay, so it have no, mark my words. Okay, take a note. It have one clock is there. Okay,
Okay.
in every positive edge of the clock. Okay,
Yes.
okay, you have one variable called count. Okay, it should we can take it as reg type. Okay,
Count.
okay,
Okay.
that count need to be increment from 0 to 15. Okay,
Hmm.
1 5.
Okay.
Okay,
Okay.
then once it reaches 15, again it's need to be decremented from 15 to 0. Okay.
Okay.
Okay, once it reaches 0, it need to be fourth back. Okay,
Okay,
got
sir.
it? Yeah,
Yes, sir.
first positive edge of the clock value should be 0. Second positive edge. Okay, in between that I don't need to increment it up to 15. Okay, this action need to be take from only the edge of the clock. Okay,
Yes, yes.
yeah, you got my question, right?
Yes, yes, sir.
Yeah, I need to write the RTL code for that. Okay,
Okay.
yeah, yeah, I'm coming back through Pavitra. Okay. So you guys need to mute yourself for this After complete, just ping me. I will come back to you. Okay. Yeah. Pavitra, you completed the Verilog, System Verilog, and UVM, right?
UVM, I'm not much aware. The system Verilog, I'm done.
Fully
Verilog and
completed.
system.
Okay. For the UVM?
UVM, only I know the basics, like classes are there, agents are there, only the few terminologies, and I know not much.
Okay. Okay, fine. So my question is that we have System Verilog is there, right? Sorry, Verilog is there already, right?
Sorry, system
Verilog,
Verilog is
Verilog language is there to verify the RTL, right?
yeah.
Yeah. So what are the benefit you are getting from the System Verilog?
We have few enhancements in system Verilog,
Yeah.
and of course the OOPS concepts that we have in the system Verilog, which makes code as reusable and readable. It's portable as well. We can use an verification. We can create a verification IP for a certain sub blocks, and we can reuse that. And it's an interface concept is there. I mean, it's so easier to use that in the interface instead of codes which we are using in the Verilog. And then to build any, we have an Verilog system Verilog, the test bench environment that we can make it useful, but not in the Verilog. We don't create any test bench environment. We have to do it in a direct way. We have to stimulate all the possible values, which makes more time consuming. In the system Verilog, we are making it more automatic.
Okay. Okay. I'm taking you some of the point you were mentioned. Okay. Now you tell that you have interfaces in the System Verilog, right?
Yeah.
Okay. So in the Verilog, while you are connecting from, let's say you have bigger one module is there. Let's say that is going to be RTL. Okay. Inside that you have multiple IPs is there. Okay. Okay.
Mhm.
So how you are connecting from one IP to another IP using the interface or any other method? How you are making the connection?
Port connection in the
Hmm.
module instantiation, we will be defining a port like
Hmm.
clock reset pin on each and every pin will be connected in the uh, if you are creating in the design, while in the half adder and full adder is there, we have to connect that within any OR gate means, then we have to connect it through port only.
Hmm.
And yeah, that one.
Port in the sense means that you need to use the wires, right? Okay, so
Yeah,
these wires are synthesizable or not?
yeah, it's synthesizable.
Okay. Then the second point that you mentioned OOP concept and reusability, right?
Yeah.
Okay. In the what is the meaning of reusability? How you are reusing the code? Okay, system value code you are reusing. You tell, right? Let's say you write one code for one RTL. Okay.
Mhm.
Okay. In the next project you are reusing that code. Okay.
Mhm.
Okay. So how you are reusing that code? In the Verilog also you can do the same, right? Next project also you can reuse the code, right?
Um,
Hmm.
okay. Yeah.
Yeah. Then system Verilog, how you are telling it's a reusability is working there.
So in system develop, we have the class concept.
Hmm.
Now I'm creating one module like uh, a Bluetooth module,
Hmm.
which I have created it, designed it, and I have verified it. Now verified with some parameters like okay, give me a few minutes. Let me come with an exact example.
Hmm. Sure. Yeah. Let me tell you the scenario, okay? You can modify on that, okay? Now you have the half order is there, okay? Let's say half order with A, B only input, okay?
Mhm.
Okay. So
Mhm.
don't forget that just an adder, okay? A, B with input, and you write the test bench in the system Verilog and the Verilog, okay? Both positive, okay? Now you are going to modify that adder into three input A, B, and C. Okay.
Okay.
Okay. Now in the sense you need to reuse the whatever test bench you wrote previously. Okay.
Mm-hmm.
Okay. In that way, system Verilog you need to do some modification, right?
Mm-hmm.
Yeah. Verilog also you need to do some modification, right?
Mm-hmm.
Okay. The both the code you are going to reusing, right? Taking the code and you are doing modification. Verilog also you are taking the code and you are modifying, right?
Mm-hmm.
Yeah. In that perspective, how your system Verilog is helping more than the Verilog test bench.
We
Oh,
can use a parameterized class in the system Verilog, which is parameterized with an inputs. Then we can pass that parameter uh, to that class, and then we can do the addition or subtraction which we want, and then we have that one more self-checking test bench in the system Verilog, which makes the result much more easier. In the Verilog we have to write the code from the scratch, like the port connection have to be changed while instantiation while instant wait, sorry while instantiating the module. We have to change the two inputs to three inputs, and also the sum and carry. While giving an input like stimulus, we have to change the like from two input we have to change that inputs to three input. As well, the result that has to be changed. um, in the two input we have only four possible combinations, but in the three inputs we have eight
yeah, those
combinations.
answer you are telling those answers are correct. Okay, it's correct. So our point is the reusability only. Okay, you tell that Verilog and system Verilog reusability is there. Okay, so my concentration is in the point of reusability. Okay, so whatever you answered is correct. Okay. Okay, check it that reusing concept. Okay, and you're aware of that randomization we have in the system value concept, right?
Yeah,
Yeah. Do we have that randomization concept in the Verilog?
yeah, we do have the randomization in
Uh,
Verilog. That's not a constrained randomization. But it will take random value as it's.
so you see that constraint. You aware of dollar random?
Yeah,
Yeah. So can we write some constraint in the dollar random?
yeah. If we can make it divisible by 2, divisible by 4 by giving the divisible modulus
Yeah,
symbol.
these things are also constrained, right, in the Verilog. And you dollar random with range, right?
Mm-hmm.
You can also make it. This is also some kind of constraint, right?
Mm-hmm.
Yeah.
Yeah.
So what is the benefit from the system value constraint you are getting?
There we will define it in a separate constraint, separate class, and then we can say, for example, now I want a value from 1 to 500. That will
Hmm.
be in the same single class, maybe. And then
Hmm.
that I can use it for one model to use it for the half adder as well as for the full adder as well. So I don't need to
Okay.
write it again and again for. But in the case of Verilog, we can't um, create that class, some separate class or constraint. We can use it for I mean, again and again. That is not possible. We have to write it manually. For if I want for one module divisible by
Hmm.
2, divisible by 4, divisible by 8, I have to manually write it. But in the system Verilog, I can create one class. I can put that constraint into it, divisible by 2, divisible by 4, divisible by 8, and I can use that as a package. I can use it in the code, and then I will reuse it in the another module as well, and in the another verification as well.
Hmm.
Yeah.
Okay. Yeah. So yeah, what review is completed? Yeah, let me give you one coding work for Pavitra. Okay,
Yeah.
okay. So you're aware of that we have a number of arrays we have, right?
Yeah.
Okay. Uh, so create one. Okay, create write one constraint. Okay, with the dynamic array. Okay,
Mhm.
you can size it this array as 10.
Okay.
Okay, so I need the even numbers in the odd position and odd numbers in the even position. Okay,
Okay.
got it.
Even numbers
Size
in
it.
even position.
No. Even numbers in the odd position, array index position, and odd numbers in the even position. Okay.
Okay.
Okay. Yeah, Ravi, you completed. You are in mute. You are in mute. You are in mute. Oh, you
Yes,
are
yes, sir.
not. Okay,
Yes,
you. Okay, you are not type the code. You just write. Wrote
yes,
the
in
code.
rough. Okay, okay, sir. I can explain it. I mean, I
Yeah,
had
yeah.
taken in
Explain
some.
the logic.
Yes, sir. I had taken the output as count variable and declared it as reg with 4 bits. So as I have to count from 0 to 15. And at every pause, and I also declared one temporary register as down,
Hmm.
which I am initializing with 1 bit 0. Uh, so when positive edge of clock is coming, I am checking whether the count is less than 15 and whether down is 0 or not. If down is 0, then I am counting it to one by one up to 15. And in the
Hmm.
next else if logic, I taken checking count if count becomes 15. When count is
Yo,
becoming.
can you take a snippet of the like take a photo of the code? Okay, I will not get it, but take the photo, and
Yes, sir.
yeah, this is I'm sharing my number. Okay, WhatsApp number. Share to this WhatsApp number. Okay,
Okay.
okay, we can discuss. I'm not getting. Okay. So here module RTL is the end module. The input is clock. Okay, output reg count. Okay, 40 bit. Always at the positive edge of the clock. Begin. If count less than 40 p111 and ndn. What is that ndn?
DN I am declaring as reg with 1 bit 0, initializing it with 1 bit 0, sir.
Where you are declared initialized
Sir,
ndn here.
sir, in out beside output, I have cancelled it, na, sir. There I have declared reg DN 1 bit equal to 0. Just above always.
Okay. Regidin, okay, it's 0, okay. And count is less than 15 and okay, if it's 1, initially it will be 0, right? NDN is
Yes, sir.
initially 0, okay, first clock
Yes,
edge.
sir.
So
Yes.
count is equal to count plus 1. Its value is 1, okay?
Yes, sir. Yes, sir.
And
And
okay, count less than 15 and okay. Add after is else if count equal to 0, NDN equal to 1. Okay, you put it as 1.
mm,
Okay, and else
and else if I have written in between, sir,
okay,
with
else if
count equal to 4 bit 00, I am making it as one down equal to 0.
okay.
And
Um,
in other last else block, I am decrementing count by one.
okay. So if it's reaching 0, you are dn is equal to ndn is equal to 0. You are doing okay.
Yes, sir. Yes, sir.
Okay. If it reaches 15, you are doing 1. Okay, toggling that one.
Yes, sir. Yes, sir.
Okay. According to the ndn, you are doing the increment and decrement, right?
Yes, sir. Yes, sir.
Hmm. Okay. Yeah. I think so. It will work. Okay. Try some logically. This is correct. Okay. It's a kind of flag you are taking, right?
Yes, sir. Yes, sir.
Yeah. This will also work. Okay. You are taking the flag, and according to that flag, you are going in increment and decrement. You are doing right.
Yes, sir. Yes, sir.
Okay. Okay. Just a minute. I will share you one more code for you. Okay. Uh, you have the EDA playground access, right?
Yes, sir. Yes, sir. I will. Uh, Sir, can I use this Vivado?
No. It's not for that. I will share you one code. Okay.
Okay.
I will share you one code. You need to draw the structure of that code. Okay,
Okay.
how it's going to be like. Okay, wait. I have that code. Check it. Share. Just a minute. Okay. Yeah, I'm sharing you one code to you. Okay, so I will share you here. Okay, chat.
Okay.
So everyone can try on this later. So I need to draw the structure of this code. Okay, I need to draw the architecture. Okay,
Okay.
if
Okay.
you check it in the Vivada or any other tool, how the structure is going to come. Okay, how the connection from module A to module B is making. Okay,
Okay.
okay, right. And Shaikh,
Yes, sir.
yeah, you completed the task.
No, actually, I'm drawing the scheme. I
Okay,
have
you're
done the
doing the
next step.
game. Mm-hmm. Okay, so okay. Okay, you can. Okay, you are go like that much way. Normally, if the mode 10 counter is there, you can do some simply. You can do it. Okay, if someone is asking in the interview, how much flip
Hmm.
flop is need to be for the
Actually, it's
yeah, how much
n
normally how
for
much flip flop is needed for the mode 10 counter to count up to mode 10.
uh, for n mod n counter, we require 2 raised to n flip flops. So
Hmm.
for let's take it's a mod
For
9 counter.
yeah, for flip flops you need, right?
Yeah.
Yeah, then this is okay. While for the exam, if someone is asked, you need to do this manual procedure, okay? But for the
Okay.
interview, if they ask you have mode 10, mode 9, you can do some gating, okay? It will work, okay? Check that thing also. This is I'm not telling correct. And one more thing, you can write the code for the Verilog for the mode 10 counter, okay? Okay, just the mode 10 counter. It need to be counted from 0 to 10, again back to 0, 0 to 10, okay, in the Verilog code.
Actually,
Here,
sir,
uh,
yeah, I'm not into that much practice of Verilog because actually I'm looking for PD domain. That's why.
okay, physical deep saying, okay, okay.
Yeah.
Tell me the thing that now you have the A is there doing the PD works manually, right?
Sorry.
Some
Could you
A's
please
are
repeat?
there to, yeah, A's are there to do the PD works. Like tools are there, right?
Yeah.
Okay, is that helping in the PD domain compared
Yeah.
to
Yes.
previous year? So how it is helping?
Uh, these tools we are using in the PD, it's actually
Hmm.
helping us to understand the errors and to verify where are the congestions are there, where are the power dissipations are there, why the propagation delays are there in the reports from the reports we get of information, and that will help us to minimize that. There are various uh, tools available of different companies to minimize the areas and uh, and to overall optimize the design itself.
Tell me something about the floor plan is there, right?
Hmm.
Okay, so if the floor plan is there, do you think the chip is going to work or not? If we did not do the floor plan, okay?
So if we didn't do the floor plan, then
Yeah, floor plan. Yeah, the chip is going to be working mode or not? Can we do the chip with working mode?
No, no, the chip will not work in the proper manner. There may be more errors because due to the bad floor plan, there will be some congestion issues, routing issues, and the circle will work, and the macros will not be placed correctly according to its requirements and where needs to be placed close by. That might lead to be the power issues, drop issues, and everything. So there needs to be a better floor plan while the chip needs to be done in the optimal way.
Yeah. So Shaiki, you can do with. I'm not much like concentrated on the physical domain. Okay, physical OPD. Okay, so
Yeah.
you can check with this. Okay, this mode 10 counter and check that what is the logic makes from mode 10. Okay,
Okay,
okay.
sure, sure, sure.
What is the common logic make? While if the interviewer asked, let's say if he asked for to draw on the half order and full order or something, you can go with the starting, right?
Yeah.
Right. So some common logic will be there. Okay, for the marks or you can some common logic is there. You can check that thing. Okay,
Okay.
and yeah, and do one more thing also. You can create one 8 cross 1 marks. Okay, 8 cross 1 marks using the 2 cross 1. Okay,
Okay.
okay,
So,
yeah, try that also. Okay.
uh,
Don't stop this work. Okay, don't stop this work. I'm telling you, you can complete this work. Okay, whatever you are doing in the using the body energy and KMAP, continue that thing, and after that check that what makes the common like common thing. Let's say
actually,
I will give you one example. If I'm asking you to write the binary code for number 20 or 21 in the
hmm,
or octal code in the college, we will going to do the divide by 8, divide by 8, divide by 8 things, right?
right, right, right,
Right, but actually you are familiar with these kind of binary values, you are like expert, then you will not going to do that thing, right, you know
correct,
the
right,
weight and how to convert it binary quickly, right?
right,
Okay,
sure.
so those things you need to implement in the digital designing also. Okay,
Okay, sir.
okay, so for the mode 10 and mode 9, mode 80. Okay, okay,
Okay,
and
so this need to be minimizing all the stuff.
yeah, minimize, of course it's going to be minimized. Okay, of course it's going to be minimized. Do this thing and after that check that parallelly. Okay,
Okay, sir.
okay, and one more thing that implement this cross 1 marks also. Okay, practice with this cross 1 marks also. Okay,
Actually, the answer is it will require 7, 2:1 mux required
yeah,
to
7.
be.
So how it's going to be looks like, you need to draw the picture also. Okay,
Should I draw in detail or just generalize? So let's just
just generalize. Okay, how it's going to be 2 4 1 marks, how the 7 to cross 1 looks like placed, and how the connection is going to happen. Okay,
okay, sure, sure, sure. Just a
okay, yeah. Next, coming to Pavitra, you done, Pavitra?
Yeah, I have got the idea, but not getting the right syntax and
You
finding.
can share the same to my WhatsApp number also. I will check the code.
Yeah.
Okay. Ravi, okay. So what I given to Ravi, I given to draw the picture, right? You completed.
No, sir, I'm doing it.
Okay.
Our first module will be clock generator, and second will be a 3-bit 3D flip flops. And
Yeah, three modules are there. Exactly correct. Three modules are there. You don't need to concentrate on the task and function. Okay, it's okay. Okay. I
yes,
need
yes,
to
yes.
get the idea that clock generator is going to generate the clock and how that other modules are getting the clock and how they are working. Okay.
Okay.
Okay. Yeah.
Yes, yes.
Yeah. Yeah. You shared, Pavitra?
Yeah, 1 minute.
Okay.
Let me share it to the WhatsApp.
Ravi, in this code, each line you are aware of that, right? What is the meaning of the line you are not?
Interface I'm
Uh,
not aware of, sir, but I have searched about interface just now. What is
uh,
interface? I came to know that we some little thing. I'm based on that
yeah, yeah.
I'm
Okay. Yeah, that's the
required.
thing. Yeah, that's the thing you also need to. Okay, so if you're not aware of that, you can search it. Okay,
Yes, yes, yes.
so okay.
Sorry to interrupt you.
Hmm.
So the starting four mux require the common select line, and the next mux will require the select common select line, and the last one like this.
Okay, cross one, two cross one marks two input. Yeah, seems it's correct. Three. Okay. 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 For the 64 cross one marks. Okay. Let's say 64
Hmm.
input is there. Output is going to be one. How much select lines you will going to have?
For 64,
Hmm.
using 2:1.
Not using. Okay. If it's two
Acha,
is to one, also same select line is going to be same, right?
right, right.
Yeah. How many bits of select lines you need?
Okay. So, so six select lines, sir.
Okay. Okay, fine. Okay, so you can continue that other work also. Okay,
Okay.
and what question I given to you that more than counter. Okay, more than counter in the Verilog it's not a big thing. Okay, it's a simple thing. Okay, you
So,
don't
no,
need to.
I just want to ask. Okay, I will do the practice of that.
Hmm.
So, as a PD, do I need to practice Verilog as well?
Of course, you need to practice, right? As a fresher, they will going to ask you the Verilog, okay? Definitely, they will
Okay.
going to ask you the Verilog, okay? Because this is a Verilog, it's for common, okay, for the VLSI, okay? Maybe they will
Okay.
not ask, but it's also because whatever you are digital designing, you are going to be the Verilog, right?
Okay.
And this is Verilog is not that much big, okay? You need to no need to flip flop four flip flops. You need to implement those concept. The tool will going to give you that architecture, okay? It's just a or 4 or 5 lines should be there for your counter mode and counter, okay?
Okay.
So
Understood.
you need to explore the Verilog, of course you need to do, okay?
Okay, sir.
Yeah. Okay. Yeah, that's I'm stopping from you, Rahim, okay? You can do this exercise, okay?
Uh, just want to ask one last
Yeah.
question, sir.
Mm.
Uh, uh, as means for the digital design, what are the other questions they might ask, means, apart from counters and all?
For the you are a fresher, right? Which year pass out you are?
Actually, I'm at 22 pass out, and I'm
Okay.
currently working. I'm currently in a professional way, experience. So I want just want to shift the domain into PD.
Okay. So you are a 22 pass out is according to the interviewer. Okay. So you are 2 years back pass out. So they will going to check your digital concept and all. Okay.
Okay.
Definitely your digital concept and all. You need to number system. You need to be very good in number system. Okay.
Okay.
And conversion of all the number systems, okay, and the circuits like latch, flip-flops, combinational sequencer circuit, what it makes the difference, okay. Okay,
Okay.
and apart from the college time you will study that pattern, okay, a pattern that is correct. I'm not telling it's not correct, but once you are going to be a true engineer you need to do this, because if I'm giving you to ask you the question like number, what is the binary number of this value, you cannot going to take this much time, okay. So if you are taking
Correct.
this much time, that means you are not familiar with this number system and all, okay. You should need to be expert, okay.
Okay.
So okay, do that thing for this counter, okay, counter. Then other counter also there like up counter, down counters, okay. How this is going to be work, okay. And all
Okay.
those digital, yeah, digital you need to practice it, and the basic flow of full chips, okay. Maybe they will going to ask you the basic flow of the full chip, okay, and do some exercise on the Verilog also, okay.
Okay, sir.
Yeah, okay, here also syllabus is there, right? Verilog for the PD.
Actually, I'm into the interview basic. That's
Okay, yeah, okay, fine.
yeah.
Okay, I'm stopping
Okay,
from
sir. Thank you.
yeah, thank you. Yeah, Pavitra, you did the answer for this, right? Constraint, okay. So module TB is there. Uh, end class, end module. What is this module, Pavitra? Hello?
That's a top module.
Sorry?
That's a top module. That's a top module where the actual dynamic
Okay.
array has three.
Yeah, yeah. I don't need to do this all those. You need to write the constraint only. That's okay. So old constraint, constraint add. Okay. Constraint add. What is this constraint add and class even constraint int array constraint even array dollar randomize.
Yeah,
This is not the way. No, 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 no,
yeah.
no, no. No, no, this is not defined in the array. I don't want to be module and all. Okay, let's say in the class you have one. Okay, randomized by two, mode two. Then constraint dot randomize for each equal to and even if I mode 2 equal to array of I equal to constant dot randomize else even dot constant dot randomize even dot constant dot randomize. Some logic you did, yeah, that is correct. Okay, but okay. So can I ask you one question? In the randomization, we are using the randomize method, right? Right?
Yeah.
Okay, to randomize the whatever the value coming from the transaction. You know the structure of the system value class, right?
Yeah.
Yeah. Tell me the architecture of the system verilog test bench
Uh,
architecture.
Placements architecture. Yeah,
Hmm.
it's a we have generator and
Hmm.
then we do have a monitor, a driver which drives the data,
See,
monitor,
while telling, tell me the correctly. Okay, you are jumping from here to here. Generator, then monitor, generator, then driver. Tell me with
generator,
each
driver.
functionality. What is the? Hmm.
Yeah, generator which generates the data for to test the DUT. Driver will take the data and it will send data to the DUT, and
Hmm.
as well monitor receives the data from the driver, and monitor will send the data to the
Monitor.
reference.
Wait. Monitor will going to receive the data from the driver.
Yeah,
Okay, then what is the purpose of the interface you have there, right?
that is to send the data from driver to the DUT.
Okay. Then let's say you have an address there, a plus b, output is y, okay? Okay.
Okay.
Okay. So for the analysis, you need the output also, right?
Mhm.
So how the monitor is getting the output value of y? From the driver.
That we must have a separate monitor called read monitor that we will be getting receiving the data from the DUT, the output.
Okay. So you are going to be use two monitors.
Yeah, this write monitor is to
Uh,
uh, know what we are sending, what data we are sending to the DUT, the
uh,
inputs that we have to send it to the reference model to get
uh,
the expected output, and then actual output we will be receiving from the DUT through the read monitor, and we are going to compare with the expected result which is coming from the reference model, and as well the actual result which is coming from the DUT
okay. So for the generator and the driver, how you are making the connection?
through mailbox.
Okay, so the generator is going to generate the transaction from which packet? You need to declare some packet or transactions, right?
Mhm.
Okay,
Yeah.
there you are using the randomization method, right?
Yeah.
Okay, so there you are going to constrain it the values, right?
Yeah.
Okay, so as per your code, you wrote the constraint in the module, right? Why you are go with that? Two classes are there, then you are doing some constraint on the classes. Two classes are there. Do you think it will work? Two classes are there, that's okay. Then in the module top you have an array is there, then you are constraint dot randomization, constraint dot randomization. No. Okay, so you are probably going to write the constraint in the generator, okay? Okay,
Mhm.
So whatever logic you wrote, I think it's correct. Okay. In the mode 2, if it's even position, you're storing the array value. Okay. Okay.
Mhm.
But if someone is asking you to write the constraint, don't go for the class and module. No need. Okay. Okay. Just
Okay.
write the constraint only. Okay. Focus on the constraint only. Okay.
Mhm.
Constraint only,
Okay.
and write the constraint in the one class also. No need constraint name, and you will have inside the class array should be there. That array you need to constrain it. Okay.
Okay.
Okay. Okay. Where the constraint is going to be used, all those things you need to know. Okay, exactly. Okay. Okay.
Yeah.
So I think you got some logic is there, is correct, but it's other thing. Okay. And yeah, I shared you one code also for this ED playground link, right? Yeah.
Mhm. Yes.
You
No,
see
I
that?
didn't receive any. I didn't receive any code.
Okay, let me share it. Not a WhatsApp. I shared it in here in the chat as a message.
Yeah.
Yeah, you can draw the architecture of the code. Okay.
Okay. Yeah. Sure.
Okay, architecture of the code. So then you are aware of the. Let me ask you one more question. You are aware of the assertions and coverages, all those things.
I'm not aware of assertions, but I do know the functional coverage and code coverage.
Functional coverage and code coverage. Okay. Okay. And what about the arrays you have in the system? Well, you have number of arrays is there, right?
Yeah, fixed array, dynamic arrays.
Okay. So let's say I am asking you one question. I need to save some 100 values. Okay.
Mm-hmm.
Okay. 100 values. So without using the array, is that possible to save these 100 values in different variables or different locations? Normally in the different memory.
In a different memory.
Hmm.
Um, while declaring, we have to declare while allocating memory space to store the data, we have to declare one array. Maybe here we can use associative array to store hundreds of data, but we must declare some day, I mean, memory for storing the data. So without declaring array, I think it's not possible.
So symbol. Okay, symbol. I'm asking you a question. You have different number is there from 1 to 100. Okay.
Mhm.
Okay, I'm asking you to store that values in some place. Okay.
Okay.
Okay, some place, and later on if I'm asking you the question, where all the values are there. Okay. Okay.
Mhm.
You need to show me where are the values you were saved. Okay.
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 Mhm.
Normally is the 10 number is the 10 roll number for some student. Okay. Okay, for
Mhm.
this you will going to take the array, right?
Mhm. Yeah.
Okay. I'm asking you that question. Without the array, can we save this number or not? If I'm not going to use the array, can I save this number to
Mm.
any other method using any other method? Maybe if you complete, you can send on the WhatsApp the picture.
Yes, sir. Basic I have sent. I can explain better. Basically,
So
this.
we don't, sorry to
Yeah.
interrupt, but we don't have any other option as far as I know.
So what is this array? Array is kind of different location, right? Number of location, right? So
Yeah.
if you are declaring some 100 variable and each value you are going to save in the variable, right? Right? You can save it using the variable also, right? A1, A2, A3, A4, A5. If you declare it, it's 100 times. Each value you can save it in the variable, right?
But we have to declare it in the 100. 100 variable.
Declare it. That's what I'm saying. Any other way is there? Okay, you can, right?
Uh,
Yeah,
yeah.
you can. Okay, so possibilities there. Okay, and one more question. Okay, you are tell me that randomization. Okay, can we verify the DUT using without randomization?
Yeah, we have to use the direct stimulus then, directed value without the direct value we have to use to send the data to test it.
So can you tell me one real scenario like we used the constraint to limit the value to verify something?
Um, Say for example, if FIFO that we can use it in the say for example, if we want to use only the location 1 2024, then the randomized the address location has to be inside 1 2024 only, but not more than that. That way we can use the constraint.
Okay.
Fine.
So interface, okay. Yeah. Okay, so Ravi, you don't need to deflip of and all, it's not going to come here, okay? Okay.
Okay.
So
A
okay,
second
so
image that I have sent, that is fine.
second image you have sent, module send and receive is there, send data, receive data. Okay, so it should be in the one top module should be there, okay? Okay.
All this in the top module, and in the top module itself, there is a clock generator as well.
Where is the clock generator? Clock generator is a separate module, okay?
Yes, yes, yes. Inside
Yeah,
the top
separate
module,
module.
I'm
Hmm.
saying, sir. I mean,
Okay. Okay. So you see that two wires I declared in the module top.
yes, sir.
In
Yes,
this
sir. Clock and
picture,
tracer.
yeah, in this picture that wire is not getting come. Okay. Okay.
Mm.
So you have Vivodo is there. Okay.
Sir.
Vivodo is there, right? Tool.
Yes, 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 yes.
Okay. Try to generate actual diagram for this. Okay.
Okay, okay.
Okay. Try to generate actual diagram for this and how it's going to become like you will come to know. Okay.
Yes, okay, sir.
So no, things or practice need to be because we you will get the code for the RTL or TB. You will get the code and block diagram. Okay, diagram for that code. Okay. So
Mm.
the main thing is that you need to understand this code with the diagram. Okay. This is a
Okay.
simple code, but it's going to become very big perspective. Okay, so to come this clock generator, how this is coming, how this is connected to the interface. Okay, how this is
Yeah.
connected to the wire. Okay. Okay, so this practice need to be important. Okay, if you understand the diagram correctly only you can debug. Okay. Okay, so
Yes.
yeah, so try to do these things. Okay, if you are not getting, I will give you the clue. Here you see that clock generator is there, it's going to generate the clock and reset. Okay.
Yes, yes.
Okay, and interface is there. Okay.
Sir, can I explain it once? I mean, in the interface, there is some clock generator and there is one D flip flop which is of 3-bit storage, and the sender, this S
What
module
is
is.
this D flip flop? D flip flops. Where you get this D flip flop? This flip flop idea and all, you see that if you are seeing some chip diagram and all, they will not give you the deep flip flop or flip flops idea. This is the lowest level of architecture. Okay. So
Okay.
I don't need to want this deep flip flop. Let's say if you declare one range variable is going to be deep flip flop. This no. Okay, it's I don't need to want that. Just a block level understanding. Clock generate is going to generate the clock. Okay.
Yes, yes, yes.
Okay. It will given to the interface through the module top through the wire connection. Okay.
Okay.
Okay, now the interface is getting the clock through an argument. Okay, got
Mm.
it. This interface is going to have the module A and module B using the same interface. Okay,
Yes, yes,
while
yes.
module A and module B instantiation, you can see that whatever interface you are instantiated in the module top, you are giving to module A and module B same interface.
Yes and R you mean, sir? Module A mean.
Yes, same interface you can see that.
Okay.
Okay, and this interface is getting the clock and this connection from the module top wire. Okay,
Okay.
through for these wire you are giving the clock and reset, actual generated clock and reset to this wire to interface. Okay, interface to module A and B. Okay, with this understanding you try to draw it. If you are not able to, just ping me, I will give you the picture also. Okay, try
Okay,
to
sir.
you yourself. Okay, if you're not something you are not find it now, just google it interface and what is it. Okay,
Okay, sir. Okay, sir.
So
try to use it. Yeah,
we can end the session now. So
yeah,
because we
that's
have
it.
the
Yeah,
class,
Ravi.
so we
Okay.
will continue it in the second round. Fine.
Yeah, okay. And Pavitra also you did got this understanding, right? Let me 2 minutes.
Yeah, I'm doing.
Yeah. You do it. Okay, do it. Okay. Share me the same. Okay, same thing in the WhatsApp. Okay.
Yeah, sure.
Okay. And this link. Okay. Link whatever I explained to review also same thing. Okay.
Yeah.
Okay. Try to understand it. Okay.
Yes, sir.
Okay. Yeah.
Okay then.
Any
Thank you
other
guys.
doubt? Yeah. Bye.
Thank you everyone.